Next, we'll find the angle between two vectors. The cosine of the angle between two vectors equals the dot product of the two vectors divided by the magnitude of one vector times the magnitude of the other vector. So visually, what this is talking about is if vector u is going this way, and maybe vector v is going this way, we're trying to find the angle between them. Okay. So we'll use this formula in example number 3. Example number 3 wants to find the angles between vectors u and v. Part A, vector u is 2, 3, and vector v is negative 2, 5. I'm going to use the formula above. So the cosine of the angle between equals the dot product. So the dot product, again, you multiply the x's together. 2 times negative 2 would be negative 4, plus multiplying the y's together. 3 times 5 is 15. Divided by, I want to find the magnitude of u and the magnitude of v. Remember, to find the magnitude of u, it's the square root of the x-coordinate squared plus the y-coordinate squared. So what I'm going to do is the square root of the x-coordinate squared, 2 squared is 4, plus the y-coordinate squared, 3 squared is 9. For the magnitude of v, I'll be doing the same thing, but for vector v. So the square root of the x-coordinate squared, so negative 2 squared is 4, plus the y-coordinate squared, 5 squared is 25. From here, I'm going to simplify a little bit. Negative 4 plus 15 would be 11. 4 plus 9 is 13. And 4 plus 25 would be 29. Now we get to use our calculators. So in your calculator, to find theta, you'll do the cosine inverse of this fraction. There are a lot of parentheses to remember, so if you want to, you could also do it one step at a time. So in the calculator, I'll make sure that I'm in degree mode, which I am. Now I'm going to go do the cosine inverse of 11 divided by, I need to use parentheses, so I divide by everything I want to, be the square root of 13 times the square root of 29. So for the first problem, the answer should be about 55.5 degrees. Next, we'll talk about orthogonal vectors. Orthogonal is kind of the perpendicular for vectors, but a little bit more specialized. Orthogonal vectors are vectors whose dot product is equal to 0. Interestingly, the 0, 0 vector is orthogonal to all of the vectors. Example 4, we will prove that the vectors u, which is 2, 3, and v, which is negative 6, 4, are orthogonal. To do this, to prove that they're orthogonal, I need to show that their dot product is equal to 0. So I'm going to do the dot product, u dot v. To do the dot product, you'll multiply the x-coordinates together. 2 times negative 6 would be negative 12, plus multiplying the y-coordinates together. So 3 times 4. 3 times 4 is also 12. Negative 12 plus 12 is equal to 0, which means that it is orthogonal. Okay. One thing you might be wondering is if this is what happens if they are perpendicular, what would happen if two vectors are parallel? Parallel vectors, there's 3 ways that you can look at it, and it depends on your point of view. One way that you can look at it is that the two vectors are really the same, but one of them is just multiplied by a scalar number. So for example, the vector 2, 3, if you just multiplied it by a random number, you could pick any number you'd like. If I multiplied that vector by, let's say, negative 2, that's a scalar number. I would get the vector negative 4, negative 6. Those two vectors are parallel. So if you can find a scalar number that you can multiply by the first vector, to get to the second vector, they are parallel. Another way you can look at parallel vectors is that the angle between the two vectors is either 0 degrees, which is where they're going in exactly the same direction, or 180 degrees, which is where they're going in opposite directions, but they're still parallel. You can use the cosine formula from the previous page to find the angle between two vectors. The last way you could look at parallel vectors is that they have the exact same direction angle. So from day 1, the direction angle is the tangent inverse of y over x. If they have the same direction, then they are parallel.